Hello, so we are going to continue on with putting our exam advice into practice, and we are going to look at part B of the question from 2017 paper 1, question 4. If I open that up and close that. So 2017 paper 1, question 4, and we're doing part B of it. A square has side length of 2 centimeters. The midpoints of the sides of this square are joined to form another square. This process is continued. The first 3 squares of the process are shown below. Find the sum of the perimeters of the squares if this process is continued indefinitely. Give your answer in the form a plus b root c centimeters, where a, b, and c are natural numbers. Okay, so what jumps out at me? I'm dealing with a square, so if I have my picture, I've blown the picture up slightly, so my length here is also going to be 2 centimeters, and 2 centimeters, and 2 centimeters. So half of it is going to be 1 and 1, and this length is 1, and so on around. And it says the first 3 squares are written here. When I first looked at this question, I actually could only see 2. Now, maybe it's obvious to you, but the fact that it said 3 is what told me I needed to look more closely. So the first square is the big one that you can see around the edge. The second square is the one that is on the diagonal. It's a square over on its side, and then the third square is the small one in the middle. That's the first bit of figuring out I need to do for the question. Then the next thing that jumped out at me is I'm seeing that I have a pattern going on here. So I'm dealing with sequences and series. So I have my page 22 open in my log tables, because I recognize that I've got a sequence and series question going on. I'm dealing with a sum that goes on indefinitely. So that tells me if I'm reasonably up on my sequences and series, I have a sum going on indefinitely. Indefinitely is another word for to infinity. It just keeps going. So I only have one formula for the sum to infinity. So I'm going to write it down. It's on page 22, down the bottom of the page, and its sum to infinity is a all over 1 minus r. I haven't figured out what I need to do with the question at all yet. I just saw a sum that goes on indefinitely. That means I'm talking about an infinite sum. So I don't know what I have to do with that yet, but I now know that it's going to involve the infinite sum formula. Now I'm looking at the fact that I'm told that it's the sum of perimeters of the squares. Okay, so I'm looking for the perimeter of my first square, the perimeter of my second square, and the perimeter of my third square, and that's going to give me a pattern that I'm going to be able to follow. So I now have a pretty good idea of what I'm doing, and I'm going to break up my page into 3 parts. And again, if your handwriting is neater than mine, you can probably get away with 4 parts, but I'm going to break it up into 3 for now, and I know my answer has to be given in the form a plus b. So my sum to infinity is going to equal a plus b root c in centimeters. I'm not given any, because it's in this form, I'm not told anything about decimal places. So that's what I've got out of my question so far, and I can work out the perimeter of my squares. So I've got the perimeter here is the perimeter of my first square is going to be, so stage 1 of my pattern, so I suppose I can call that P1, perimeter 1 or stage 1, is going to be 2 plus 2 plus 2 plus 2. It's the perimeter of a square of side length 2. Add that all up and I get 8 centimeters. Now I want to find out what my perimeter of my second square is going to be. So I am going to try and find that. It's a hypotenuse of a right angle triangle is what jumps out at me here. So I'm going to find the hypotenuse of that. So I'm going to have for my second perimeter, I'm going to need to find that out. So it's going to be h squared is equal to 1 squared plus 1 squared. We're using Pythagoras' theorem. We rearrange that out, and h is equal to root 2. So then my perimeter in stage 2 is going to be root 2 plus root 2 plus root 2 plus root 2 is equal to 4 root 2s centimeters. My third perimeter. Alright, so this length here is going to be half of root 2. So root 2 over 2. This length is also going to be root 2 over 2. This length here. And I'm now looking for this one. I already used h, so I'm just going to call this length x. So that the side length for my smallest square is going to be x. And I'm going to have x squared, doing Pythagoras again, x squared is equal to square root of 2 all over 2 squared plus square root of 2 all over 2 squared. I put that in my calculator and I get a half plus a half, 1. So x is equal to 1. Because when you get the square root of 1, it's just 1. So my perimeter is going to be 1 plus 1 plus 1 plus... Sorry. 1 plus 1 plus 1. There. It's going to be 4. And that's all of the ones that I've been given, and because I know that I have a geometric series, because that's the only type that has a sum to infinity, I'm now just needing to find out my first term and my common ratio. I can see I need an a and an or for the formula that I know I need to use. So I'm going to write out my series. I have 8, 4 root 2, and 4. How am I going to get or? I'm going to have or is equal to tn plus 1 all over tn, which in this case, it doesn't matter which one you pick, but I'm going to have 4 root 2 all over 8. Now, you're not required to be able to do this in your head. What you'll probably get out of your calculator is root 2 over 2. You may be able to work out if by thinking it through that is actually 1 all over root 2, which is a slightly nicer thing to deal with, but it's perfectly fine if you get this out of your calculator and just work with the common ratio as root 2 over 2. No marks will be taken away from you. It doesn't really cause a problem. It's just slightly less elegant. So I now have my common ratio, which I'm going to use as you would probably have it, root 2 all over 2, or is equal to root 2 over 2. And a is just the first term, which is 8. So now I'm in a position where I just sub into my infinite series. So if I do that, always write down your formula when you're going to sub into it. 8 all over 1 minus root 2 over 2. Be very careful about the way that you put that in the calculator. It's often safer to actually put it in brackets when you have a fraction next inside a fraction. When you do that, you will get out of your calculator 16 plus 8 root 2. Which is lovely, because that's exactly the form that you were expected to give your answer in. Now, if that didn't happen, so I really recommend that you do this on your calculator. If your calculator is not set up to give an answer like this, it could cause you problems in the exam. I know the Casio ones do work that way. I know there are versions of the Sharp calculators that don't. So make sure that your calculator that you are working with will give you an answer like this, is set up to give you surds when it is appropriate to give you surds. So that is my final answer, and I'm going to write it down here where I have my setup. Is equal to 16 plus 8 root 2. don't forget my centimeters because I wrote it there to remind me. That's my answer. Now, we're going to have a quick look at the marking scheme for this question and see where it is that we picked up lots of marks. Where were the steps? Okay, so just be prepared, the screen is going to get a little brighter. Now, we have our marking scheme for this question. So, what we've got is our low partial credit is 5 out of 10 marks. So 50% of the marks for the question is going to go for getting the length of one side of a new square. Where does that translate to in where we got to? It translates to here. By the time we got this, we've got 50% of the marks for the question, which isn't doing too badly. So at this point, you've got 50% for this part of the question. 5 out of 10 marks. Skipping back. High partial credit, so 80% for the question. Sum to infinity, correctly. Fully substituted, correct work with one side only. Okay, well, fully substituting into your infinite series comes in, that's actually very close to the end. So mucking up your final answer cost you 2 out of 10 marks. So subbing into your formula here gets you 80%, which admittedly is the vast majority of the question. However, you get 50% for getting to this point. So even if you just saw that you could get the side length of our second square and you couldn't think about anything to do about sums or sequences or anything like that, you've got 50% for this question just for recognizing that you're looking for the side lengths of this square. I'm not sure what just happened there, so we will call our question good at that.